We use a lot of technologies there, not just the programming languages I showed you before, but we use a ton of stuff, including PHP and a bunch of other things. It's super, super fun. We're also hiring. We hire lots of devs and tech people and product managers and project people and businessy people all the time. Come hang out. It's a great place. It's lots of fun. Very, very laid back, very cool things. GraphViz is a tool that we use at Cinecore. GraphViz is a tool, kind of like in HTML, you can write a text file and then get back out graphically image things, like layouts and stuff. GraphViz is very similar. You write a text file, and then it will produce for you a directed graph of whatever thing you're trying to express. And everybody works with directed data, whether they know it or not, especially for things like system architecture. Like, these clients talk to this load balancer, which talk to these servers, which talk to this database, and you can express this not in some awful Visio diagram, but in like a nice simple text file that you can really edit easily and update and store and get, and it's wonderful. And you can make it as big and complicated as you like. Perl has this interesting feature where if you write a function that takes a function as an argument, like this one, where it just calls the code that you put in forever, and you say to Perl, actually, this function has a prototype that says the first argument is always going to be a code reference is a function. Then you can call it like that and just put curly braces, and you can make these sort of fake syntax things. So you can do something like make a fake userland if syntax. So I make if, which goes through all the things you pass it, takes the first one as the conditional, and the second one as the thing, and if it's correct, then it calls that and then jumps out. And then I have some other things down there that simply act as like pass-throughs for those fields. And then you can write code like this. And of course, this isn't as useful when you're talking about if statements, which it already supports, but if you want to make some other syntax, like a try-catch block, or anything else you can imagine, then you can make stuff in userland without writing any C code at all that looks like a real Perl syntax. And that's great. So trigonometry, who's scared of trigonometry? Don't be scared of trigonometry. It's so handy, it's not hard. So you have a point out of the coordinate system, right? You have an x coordinate, you have a y coordinate, and that's how you get to it. But you can also get to it using polar coordinates. You have a distance away from the center and how far it is around from the x-positive axis, usually. To convert between these, you can just do this. This will give you the rotation, the angle, and whatever your atan2 function returns, probably radians. And it'll give you the distance away. And if you want to reverse it, you do that. That's it. If you memorize these and just ignore all the rest of trigonometry, you'll be able to do 90% of the kinds of things you need to do to have anything with a facing in a direction, move around in a game, or anything. Like, that's it. You're done. So don't be scared. It's easy. When I talk about language design with people, I often talk about operators, and it's very useful to have a common language to be able to talk about operators, like, for example, PHP's ternary operator that we just heard about. And one of the properties of an operator is its arity. The arity is to how many things does the operator apply. A unary operator applies to one thing, like a not. A binary operator applies to two things, like a plus. A ternary operator applies to three things, like that. The reason that is called the ternary operator is because there's only one. If there was only plus, you'd call it the binary operator because there's only one. So there's also precedence. Precedence is given different operators on different levels of precedence in different groups, which one should you apply first? So if star is higher, you would apply it as if it were parenthesized like this. If plus were higher, then you would parenthesize it like this. And that has to do with how the expressions are broken down into a syntax tree and how it's processed back together and what the values are, of course, because it's going to be totally different things. There's also associativity, which is given operators of the same precedence level, two different operators, or two of the same operators next to each other of the same precedence level, in what order do you apply them? So if you have A minus B minus C, if it's right associative, you do the rightmost operation first. If it's left associative, you do the leftmost operation first. And depending on how you set up your associativity, you can do things like totally break the ternary operator in PHP. There's also fixity. Fixity is to which operands the operator applies. A prefix operator, or a unary operator, applies to the thing right after it. It goes before it. It's prefixed to it. A postfix operator, like the postfix incrementer, applies to the thing before it. It goes after it. It's postfixed to it. And then you have infix operators, which apply between something, and you have postfix operators for binary, or prefix operators for binary, sometimes called Polish, reverse Polish, which take two and like start grabbing from out further away from itself than the things it's touching. And different languages have different kinds of operators with different properties like these. here's one that I mentioned before about why I like Perl so much. If you want to do an array map, that is to say you have an array that has some values in it, you have a list of nodes that you want to get all the parents from, or you have a list of employee objects and you want to get all the names from, or you have a list of numbers and you want to square them, like in this example, you do something called a map operation. Instead of writing a giant for loop, all you have to do is a map that says, take each element of the array, apply this function to it, build a new array out of the return value of that function. So here in PHP land, we have array map, the function, which takes another, well, the name of a function as its argument, which then looks up in your namespace, which is creepy anyway. So you have an array 1, 2, 3, 4, 5, you have the square function, you tell it, make a new array output based on the input, square all the numbers, and now output is that. In JavaScript, you do something kind of similar. You have an input array, you call map on it, you pass it the function that you want to do. In this case, functions are first class objects, so you can pass it right in without having to give a namespace thing. And then the output is that new array. In Perl, you can do something very similar. In Perl's map function, the underscore variable, $_ also called the topic, is set to the current thing, and then you provide a sub. You should recognize this syntax from the userland sugar that we just showed a second ago, where it says the return value, being the last value of the expression, is the thing you have multiplied by the thing you have. And you can specify something like this, and it does exactly the same thing, but it's only this many bytes instead of this many bytes, and it's faster. I've highlighted in blue the boilerplate not related to the task at hand of squaring a bunch of numbers in a list. PHP's makes me very sad. JavaScript's only makes me kind of sad. Comparison operators in PHP. This is really funny. So we're not just talking about double equals anymore because, yeah, okay, never use double equals. Fine. But you still have less than and greater than, and it still matters. And they still do different things based on the operands, just like double equals does, except they're way harder to ignore. So if you have two operands, you have this giant table to figure out what kind of comparison you're going to do, and it could be any of those every single time you do it. Which leads people to build tables like this that say whether or not these two things compare double equalsly. The fact that this even needs to be a thing that exists at all in your language means that you should probably stop using that language entirely. I tried to make a digraph. So we used graphics a second ago. I made a digraph of all of these values that were interesting and how they relate. So if something is bigger than something else, there's an arrow pointing to it. If two things are the same, I drew a green line between them, and I got this out, which kind of is indicative of something. So I tried to simplify it, and I tried to simplify it more, and I ended up finding that there's a certain subset of values that produces a perfectly transitive subset. That is to say, for all of those values, they behave reasonably inside that set alone. And then there are a couple other values, null, false, 0, negative infinity, positive infinity, true, and 1, that behave weirdly for that transitive subset in certain cases. And I built this table. This table is interesting. The blue part is the transitive subset. The orange part are exceptions. The green parts are things that are co-equal in those groups. And the red part are things that violate the transitivity and go backwards. Which means you can make loops. Which means that if you write a code like this, where you have three values, you have inf, array, and an object, and you say var dump a is less than b is less than c is less than a, one of those should be false. They're all true, which means that you can also do stuff like this. If you have a sort function and then an is sorted function that checks whether or not your array is sorted because all the values are in the right order, and you put those values in the array and you call sort, it's still not sorted. PHP sort function can return unsorted arrays sometimes depending on what the values are. What? Git. Who uses version control? Who doesn't use version control? Good. Who doesn't use Git? See me after class. Git is really easy. Don't panic. Some people use Git just like a little bit, and some people use Git a lot. You could start a new Git thing like that or like that. If you have a new Git thing from scratch, use git ignit. If you have a Git thing that you want to share, like something in GitHub, say git clone the thing. Now you're in a Git repo. Done. That's it. If you want to put new stuff in your Git repo, say add and then commit. If you want to push stuff up to where you got it from, you say git push. If you want to get stuff that's new from the place you got it from, you say pull. That's it. If you just do these, you're already fantastic. The cat theorem is really, really important in distributed systems like the internet. Has anybody used the internet before? A distributed system cannot be simultaneously consistent, available, and partition tolerant, is what the CAP theorem says. Consistent means it only returns the correct answer ever. Never ever returns the wrong answer for anything. Available means it always returns an answer. Partition tolerant means it even works while there's a network failure. So we have these two fictitious nodes, and their job is to be a key value store, except we're only ever storing one key, x, and the value of it. Very simple system. Two nodes, they work together to store this value x. And you do something like, hey, x is 1 now. Okay, thing, x is 1. And it says, oh, okay, I'm going to update just a second. And it goes back and it says, oh, node 2, hey, x is now 1. Okay, got it, great, thanks. And then it comes back to you and says, okay, I'm done. X is 1 now. Fantastic, everything worked. It was consistent, it returned the correct answer, success. It was available, it returned an answer, success. It was not partition tolerant because there were no partitions to tolerate. What if there were a partition? Well, now, node 2 has 1 from last time, but node 1 has kept going and now it has 0, or they're out of sync for whatever reason. Anyway, now you come to node 1 and you say, hey, what's x? And it says, let me check. Oh, walls. I have no idea. At this point, it has to make a choice, and this is where the CAP theorem becomes important. It can choose either to be consistent and say, I don't know, or it can choose to be available and return whatever answer it has that it thinks is best, even if it's wrong. In this case, it's wrong because node 2 has a better answer for x, but it doesn't know that, so it has to choose either to give stale data or no data. So it's partition tolerant. It's during a partition it works. Works, depending on how you define works, but it is either consistent or it is available, but not both. There are a bunch of Perl inline modules that are really funny and neat, but mostly funny. So you can do things like a here doc. Here's a here doc, just like in PHP, except mostly like PHP. You could say use inline Java and then give it a Java class, and it'll go and compile that class for you. It will boot up a JVM. It will set up an RPC system. It will make it so that you can instantiate that class in Perl code, call methods on it, get results back, and it's actually running Java code. This is real. It returns 42. You can actually do that. You can do it for Python too. Does a very similar thing. You can create a Python function that makes the sum of two numbers and returns them, and then Python sum there, that function that it figured out just by inspecting the code, is callable in Perl now, and you can use it. You can integrate with Python code. You'll notice that there's no C or anything in any of these. It's just that. That's all you have to do when you're done. You can do this with Lua. You can make a Lua function and then it just is magically available. You can do it with C++. Here's a C++ class. I instantiate the C++ class. I call a method on it. It works. You can do that. You can do it with C. Here's a C function. You just call it. It works. You can do it with BASIC. I don't know why. You can. You can do it with assembly. You can do it all at once. It still returns 42, by the way. It just takes a while. So I put a programming language in your programming language so you can interpret while you compile. Vanilla.js. Who's heard of Vanilla.js? The site, not the thing. The site is funny. It's actually just the thing. But the speed comparisons on Vanilla.js are real. The Vanilla.js site is basically saying, think about not using a framework maybe. Like consider that as an option. And it has speed comparisons that are like, how long does it take to simply do get element by ID, which, if you think about the implementation, should really just be a hash lookup into something. Ops per second. Dojo is half of that. jQuery is here. This is how fast your program is going. Something else, like get elements by tag name, is even worse. Because these cannot fake the magic that the browser does when it just returns a magic dynamic list that it fills in runtime as you ask for them. These things have to go and get them all. This isn't an error, this is the bar graph. So consider using just plain ordinary JavaScript for some things where you don't need $thing equals thing, just call the function, it'll work. How many of you use screen, like GNU screen? How many of you don't? See me after class. It'll keep your console programs running if you log out or disconnect it. If you don't do anything other than this, just when you log in, run screen, and then forget that you're in screen, and you're fine. You can also run lots of other cool stuff. You can run several things at once by having several windows inside of the screen instead of SSHing in for every single connection that you want to do. And if you lose your network connection, all of your programs die. The screen will just keep them running. Come back later, reconnect, you're all set. And a billion other reasons that I don't have time to talk about in a minute. Basically, you type screen, now you're in screen. It'll look exactly the same because it tries to stay completely unobtrusive. You can see what the sessions are on your screen by doing ls. You can reconnect to one by using gr. Inside of screen, when you say Control A says, hey screen, listen to this. And then the next thing that you type is the thing you want screen to do. You can make a new window with C. You can switch to the previous window by doing Control A twice. You can switch to a specific window by giving its number. You can get a list of all the windows with double quote. You can rename a window with capital A, otherwise it'll all be named bash or something. You can detach from screen with D, although you can also just close your terminal emulator and it'll just stay open. And if you actually want to send a Control A, and it'll send one. I made a funny Perl script that lets you browse fractals in your terminal interactively in real time using Wastl and stuff. So if you run that, it gives you this in your terminal. And it also has support for 256 colors and other things like that. This uses inline C to be really, really fast, which is neat. And it's a very small program. So if you want to read it, it's there. And it shows you how to use inline C to make your programs fast and do some very simple terminal browsing things. It uses, actually I think it uses NetHack keys like up, down, HJKL stuff, I forget. Anyway, play with that, it's a lot of fun. So you can do some really interesting symbol table hackery in Perl. So in my PHP Centers talk, I mentioned that the symbol table hackery that PHP does is scary. This is also scary, but it's not as scary, and it's also awesome, and it's also not like verboten. So suppose you have this very simple function. You have like a class system somewhere that has this object greeter with this method greet, and you call it with an argument, and it says hello to that thing. Elsewhere, some call stack far off someplace in some code that you're trying to test, it calls this. This comes out. You can write this code. You can say, give me a reference to the old one, and then totally replace the new one with this other function that says name, nope, and then greet pants instead and return that value. And then if you call it, hello pants, this is handy in weird cases. So try not to think about production code for a second. Think about other things. Think about things like writing a debugger for your object system. We have a system at work where it'll make requests for you and then build pages together in Perl. Like it'll go and request things from all these different APIs and then throw them into a templating system and pull stuff back out. So what I did is I wrote a simple debugger that wraps certain functions in the library with something that says, hey, this function's about to be called. Here are the parameters. Do you want to tweak them? And it pauses there. Because I wrapped it like this and then called the original function later. And you can go in and you can say, oh yeah, it's calling that API. I just want to test it with this other API quick. Edit argument 2, change it to this thing, run. And then it keeps going. And then there's another hook afterward at the very end that says, hey, this thing ran. It returned an HTTP response in this many milliseconds with these kind of headers. Do you want to muck with that? And you can say, yeah, and it'll open up a Vim session. You can go tweak it. And then it'll finally return the real thing. So for stuff like that, where you want to have sometimes like a debug wrapper around certain methods deep in your code, this is super handy. It's also handy for things like if you want to write a unit test that depends on the time of day. You could do something like this. Not necessarily the best option. I've seen people in PHP have a special time object as a dependency where you just call getTime on it, and it does this simply so you can mock it. In Perl, if you liked, you could instead do something like the core global time function now always says it's 42 seconds after the epoch. And then if you call this later on, it'll tell you this. And you can just completely override it. So you can have a test that says, temporarily during this test, the core global time function now returns this value, and then call this function, and now returns this value, and then you can ask the module, hey, did those seconds elapse just now? And it'll be like, oh yeah, totally, that was like 30 seconds. And your test will be instant, but it still thinks time passed. So that's kind of cool. So if you use bash, there are some things that are very simple in bash that will make your life way easier. If you type Control-R in bash and then start typing any substring, it will do a case-insensitive backwards search of your history to find the first thing that you typed that had that string in it. So if you very frequently SSH to a box that's got some really long obnoxious name, instead of making an alias, you could just do Control-R and start typing the first characters in the name, and it'll come up and you can enter. Or you can hit Control-R again and it'll keep searching back until it finds one, or you can hit escape and edit the line and like put it into your command prompt and you can just start typing. You can iterate over lists. If you don't learn any other bash looping syntax than this, just remember for f in some glob, semicolon do, your command, semicolon done. and it'll run this, and you can put $F anywhere, and iterate over a bunch of files and run a command just with that, even if you don't learn all the rest of the syntax. That's super handy alone. If you have curly braces, and you put like comma delimited things in there, it will take all of the parts attached without like no white space, like actual string attached to either side of that, like access comma error.log, and it will produce as if you had, or it'll run as if you had done this, access.log and error.log. So if you have like a great big log file, and you really just want hours 1600 and 1700, you can put the entire giant log file name in there, and then go make a curly's 16, 17 in the middle there and replace that bit. And that's way easier than having a prompt that's this long because you have like 3 or 4 files that are all exactly the same except for one character. So that's kind of handy too. Or if you want to like change the extension on a file, a syntax like this is really handy. Just nothing on one end and comma.ext on the other, and it'll move it from one to the other. So less typing, more goodness. Here's a PHP bug that totally blew me away, that this is even a thing. So I have a function that simply returns a reference to the thing you pass in, just for ease of reading and stuff here. So if you have an array containing one element C, and you call array pop on it, but you actually are calling array pop on the reference because array pop modifies the thing that you pass in, and then you print array, but it's in parentheses, it does nothing. When there are no parentheses, it does the pop. In PHP, references are so fragile that even putting them inside of another expression causes them to collapse back to the value. I have a condition called color grapheme synesthesia, which means that if you've ever seen my terminal, to you it looks like this, because I don't have any syntax coloring on at all. To me, it looks like this. And that's really handy. I blame it on a little puzzle I had when I was a kid, not an alphabet thing. This is the actual one I played with when I was little. This is how I learned my letters, and how all the letters have colors associated with them. So when you see this code, I see this code, and that's great, because it means that all of the code, always, anywhere I see it, is color-coded, and that's wonderful. So here's some stuff about Git internals. Git has a init, you call init, you edit a file, you make a directory, you edit some other file, you say git add dot, it adds all this stuff, you say git commit. Git commit produces a commit, and now you have a commit sitting out in the open. And then it has a hash, and that represents the actual hash of all the stuff in your commit. And then you do the same thing again, and you do more work. Oh, by the way, there's a branch called master that points at it. And then you do some more work, and you commit again, and it makes a new commit pointing at the old one, so you know how you got there, so you can do things like diff with what you were before. But the branch you're on follows you around. So if you do it again, then master will keep following you, and you'll keep having new hashes. And then you can run and the thing that you're currently on is called headed. So then you can run a command like git checkout-b login page that makes a new branch with whatever you're currently at. So now you have a second branch pointing there, and now head is also here too, and then you can make commits on that. And then, say you have another developer someplace that commits a bunch of stuff and then pushes it to master, and you pull down those things, and so they add some stuff. And then later on, you say, well, head is here, but what I really want to do is pull that stuff into master. So you get checkout master, your head moves over to point at the other thing, and then you say, git merge, login page, and it makes you a new commit. That points at both things, because it has two parents now. And that's how the basics of the Git internals work. I mean, not internal so much as just the commit structure. Anyway, yeah, Vim. Who uses Vim? Who doesn't use Vim? Awesome, only a couple people. Do you guys use Emacs or something? Oh, Emacs. Anyway, so Vim is modal. This means it has modes. Don't panic. In command mode, every key does something different. In insert mode, Vim just inserts whatever you type. So some commands are motions. W moves you ahead by a word. It defines a word in a certain way. J moves you down a line. F moves you to the first instance of the next character you type. So like fx will move you to the very next x that you find. Some commands switch to insert mode. I just puts you in insert mode right where you are. C takes a motion that it deletes and then puts you in insert mode. Capital A puts you in insert mode at the end of the line. O puts you in insert mode on a new line underneath you. So once you start getting used to these things, you can just do them, and it's so fast. Capital J removes the next new line. D deletes the next motion you give it. V and capital V and control V all make selections of different shapes. Escape puts you back in command mode. Dot does the last action again. So if you have a string like this, and you want to change it from this to class awesome stuff, you can just type that. No mouse, no arrow keys, you're already done. You do FT, which says move to the first, capital T, change a word, deletes that stuff, puts you in insert mode, you type stuff, you hit escape, and you're done. so much faster. You just have to get used to it. Take a week or two. If you have a friend that doesn't use Vim, tell them just like for a week, just try it. Because once you get the hang of just the basics, it's already faster than Notepad or whatever it is they're using. I made a really dumb module in Perl. You can do this in your code and it'll actually create a box object, which is just something that knows its width and its height. It does this by overloading the tilde operator, which is bitwise negation, and it defines method or functions called O and capital I, and it uses the properties of how Perl nests and loops these things to figure out how big it is this way and how big it is this way, and lets you draw boxes in your code that don't ever do this in real code, but it's really, really funny. If you go there, you can see it and play with it. It's really dumb. I've also made another dumb one called magic tags, where I overload the angle brackets thing to let you do things like this in your Perl code. So here is Perl. Here is something that looks like PHP code, and in fact, this will run this PHP code right there inside of your Perl code. It's a statement. It needs a semicolon. And this is actually running PHP. It's not fake. It's shelling out. It also works for things like if it sees something that looks like HTML, it will print out the HTML right there. So if you have like an array of links, and then you have some HTML, and then you have a for loop, and then you have some HTML, and then you have like some stuff in there, and then you can print out some other stuff. Like you can make like whole templates. Don't actually do this. It's just really goofy. They had a hackathon at one point, and I decided to make something dumb for it. WebSocket. How many people played with WebSocket? It's so cool. I've been playing with it like the past couple days. It's awesome. So there's a couple differences. Most of the time in legacy apps, you have like traditional HTTP, AJAX stuff, and it's kind of slow, and sometimes you have long polling, or sometimes you have other stuff. And So you have like polling, you have long wait, WebSocket is instant, and you get events every single time something happens. AJAX is monodirectional, mostly. You can kind of rig up a full duplex system if you want. WebSocket is just full duplex. AJAX is full HTTP request response, headers, all the cookies, everything, every single time, user agent, whole body. WebSocket is 2 bytes of overhead for every single message. It's a packet type and then the length. And sometimes there's an extra byte for extended length and stuff, but basically 2 bytes of overhead. HTTP AJAX is mostly the same domain. Sometimes you can skirt around that with Flash or JSONP or whatever. WebSocket is cross-domain. The server gets to decide whether you can connect. The downside is that AJAX is a set-in-stone standard that's probably not going away for a long time, and WebSocket is still a draft, so be careful, but it's really cool. So I was writing a WebSocket server in Perl for fun, like you do, and I encountered this thing where my Perl WebSocket server is really, really laggy. Why is it laggy? Like, only on Windows, in any browser, the data was coming to me in 300 millisecond chunks, so I was trying to make a very simple drawing app just to play with WebSocket. And I would draw with the mouse, and it would send the request, or it would send the WebSocket packets messages back to the server. The server would send me back the stuff that it got, and by the time it got it back, it would draw it on the screen. So it only drew what it got back from the server. But when I drew, if somebody else was drawing, I would get back chunk, 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 instead of a smooth line. I said, what's going on? This doesn't make any sense. Even with all the appropriate flushing, I was using a Perl module that I downloaded from CPAN to do this. I ended up writing my own from scratch. It still did it. What's possibly going on? I know for sure that I did all the flushing because I wrote it myself. It didn't happen if the browser was also sending messages. So if you're drawing and watching on the same computer, it was smooth. I'm like, this doesn't make any sense at all. The Node WebSocket server is very smooth. Well, that's weird. How come Node is different? I pulled out Wireshark and I started looking at the packets. And in Wireshark, the Node server was sending back all the packets individually, and the Perl servers were sending back packets that were literally arriving in 300 millisecond chunks. I said, what's going on? Has anybody used strace? Strace is cool. Strace is where you can run another program and you can say, print out to the terminal every single system call this thing does. This is great for debugging anything, because you can tell exactly what's going on, any proprietary code, anything that you've written, something in Perl, something in JavaScript, something in PHP, something that's a compiled C program. You can run it with strace and it will tell you all the things that it does outside of itself. Like, for example, initializing the socket. So I said, okay, Perl script. I waited until it was waiting for a new connection. I figured, it's got to be something with a socket config, something like that. I said, all right, what are you doing when I connect? And it says, it initializes some stuff with the socket and not really anything interesting. I said, all right, Node server, what are you doing with the socket? And it said, I kind of configure some stuff, and then I set TCP no delay to 1. I'm like, what? Because I was joking with my friend that whenever you have a problem like this, it's always that you forgot to set the no-suck flag to true, It is! You have to set TCP no delay to 1. And what that ends up doing is it tells the operating system, if I'm sending a small packet, normally wait 300 millis or like 200 milliseconds before sending it in case I send a couple more and then batch them all together. Way easier on the network, way less load, bigger packets, it's great. But if you're doing something like a drawing app where you actually want everything to be echoed to everybody else, you're doing stuff like that, something streaming, you don't want that at all. So you set this and it goes away. Just thought that was neat. Automate everything. Automate everything all the time. Unless you're confident that you only ever have to do it once and automating something is slower than doing it manually. If somebody says, but we don't have time to automate, you should reply, but we don't have time not to automate because it's way faster. The time savings are incredible. Figure out how long does it take to do the task, how often is it done, how many people are doing it, when will it no longer be necessary. That tells you the total amount of time that it's going to take to do this thing. Also factor in the chance for human error. What's the probability that there will be an error that a human commits? How long will that take to fix? Factor that in. If the sum total time that it would take to spend the task plus fixing all the mistakes is more than the time it would take to automate it, automate it. Automating is probably going to be faster. What shouldn't you automate? Writing code, some kinds of code reviews, some kinds of testing, jobs you're sure are just going to be one-off that are going to be easy. What should you automate? Jobs your boss is sure are going to be one-off, and most everything else. Here's some tips for giving technical interviews. Questions about facts are not good questions. Knowledge is a poor heuristic for experience, which itself is only roughly correlated to aptitude. In the real world, you're just going to look up these things anyway, so you really don't care. If a question has a right answer, it's probably a poor interview question. Instead, questions which require problem solving and let you watch the candidate think are good, because it tells you how they behave and how they think and how they operate and stuff. Always have candidates write code. Watch them for how accurate they are, of course, whether they get the right answer, but also how often do they correct the code on the whiteboard. If they keep going back and fixing stuff, and then editing and they just can't quite get it the way that they want it, or how do they format it? I once saw somebody who drew everything completely left aligned, no indenting at all, at a 45-degree slant. If that's how they communicate with you in the interview, how are they going to communicate with you when they're in your business? Probably poorly. Stuff like that. Finally, topic 30, open source your code. But it's not very good. You'll get better at it. It's okay, open source it anyway. But I don't want to support it. Well, then don't support it. This is something that I struggle with. I've only open sourced a couple things because I hate having to be that guy that says, I'm sorry, I don't really want to do this because this project is from 6 years ago and I don't care. It's fine, just open source it anyway, it'll be okay. But it's too hard. There's the command you run. It's not hard anymore. But what if nobody likes it? What if they do? What if it becomes popular? What if one person uses it and it makes their life twice as easy for whatever task they're doing? Just do it. It'll be fine. Oh, that wasn't topic 30 because I moved this one to the end. Okay, Bitcoin. One last thing. Bitcoin, everybody says, how come when I have Bitcoins I can't just copy them and make more Bitcoins? Your wallet doesn't contain Bitcoins. Your wallet contains a cryptographic signature which lets you authorize transactions on a huge distributed ledger. So to send Bitcoins, you actually sign a cryptographic document saying, these accounts hereby change in these values by these amounts, and you send it out to the cloud of Bitcoin servers that are also doing Bitcoin mining and other stuff to prevent people from taking it over, whatever. And then if the transaction is valid, that is you actually have the money to give, and you're not giving yourself 1 million Bitcoin, whatever, then once everybody knows about it, there are a couple transaction steps beyond that, then it's called confirmed, and that's the new value of that account, and that's what's in the ledger. Which means if you copy your wallet, you copy your Bitcoins, all you're doing is you're copying the key that lets you sign for things, and whatever. So my name is Wastl. These are the things. Go to these sites, type stuff in that. Thank you.